All right, this is the video for the Algebra 1 STAAR Study Guide, Lesson 5.1. Just got two left, and then you'll be done. So on the exponential equations, we're going to be basically looking mostly at domain and range, and these ideas of what is the initial and growth factor of these functions. It's just some basic conceptual stuff, and with the domain and range, it's more or less looking at the graph. And what you need to understand is all exponential functions have this asymptote, is what we call it, and it's at the zero here, my really nice straight line. But that is kind of a limit for the graph. It doesn't go below that line. Or if it's this kind of function, it doesn't go above this line. But on the other end of the graph, this continues to increase both in the y direction and in the x direction. So this line continues to go on and on and on. Even though it's not moving in the x direction very much, it will not ever end, and that's what the arrow indicates. There is an arrow here, but again, this is a known asymptote for all exponential functions. So what that means is that when I look at the domain and range of an exponential function, the first thing we need to understand is that the domain is always negative infinity and positive infinity. So right away, we're going to eliminate the domain ones that don't have negative, positive infinity. So the one that has zero here, that's not going to be part of the domain. So that's where we get either answer choice C or answer choice D. And then from there, because again, we have an asymptote at zero, that's the lowest point on the graph. So it doesn't go into the negative part of the graph at all. And so that's the main difference between these two answer choices is we have zero here. It says y is between zero and infinity, or y is between negative infinity and positive infinity. Well, we know it doesn't go to negative infinity because it doesn't go below the x-axis. So that's why we know this is the answer. And so I'm going to let you do number 2 on your own using what I just talked about. I think you'll be fine. Jumping down to number 3 and 4, I'll do number 3 for you and leave 4 for you to do on your own. But all you need to know is this. When we talk about the initial amount versus the growth or decay factor of a exponential function, the starting amount is what comes first. It is the thing that is just by itself. It doesn't have an exponent on it. The growth factor is the thing that has an exponent on it. So the 5 is our growth factor because it's 5 to the x. So that's the growth factor. And then 4 is the initial amount. And so we're going to choose answer choice B. That's what you do number 4. I'll let you do that one on your own. Then we get to number 5, which is a graph, or 5 and 6, which are dealing with a word problem kind of example of an exponential relationship. It says the park's deer population has been increasing annually by 5%. The table below shows the projected deer population for the next 4 years. The population at the year ending before the study was 12,000 deer. The equation for the situation is 12,000 parentheses 1.05x. Okay, so the important idea here is that this number here, the 12,000, being the initial amount, is the low end of our range. Okay, our range goes from 12,000 up, and our time goes from 0 up. We can't have negative time. And we know our deer population starting at 12,000. So that needs to be represented in our domain and range. So if you look at this, you'll see the only ones that match in terms of the years are going to be 0 to 4. So it's only going to be possible for it to be answer choice A and answer choice D, because the problem with this one is that it doesn't include 0 and 4. These symbols don't have the equal sign. And actually, this one is wrong because it says 0 is greater than x is greater than 4, and that is not pointing the right direction. So we actually can go ahead and eliminate that one as well. So let's talk about why this last answer choice is the right answer. It shows the domain going from 0 to 4, including those numbers, and it shows the range going from 12,000 to 14,586, including those numbers. That's pretty much it. And then you're going to do the same basic idea by looking at the graph, and you're going to pick the table that matches the graph that you have here. And just a quick hint, it's the same as the table from the previous problem, so don't overthink it. And that is going to be it for this video.